What's up, guys? Welcome to day. Shoot, I think it's 120 or 119 of programming every day. I did a little bit of off-camera, programming, or you could call it that. And I got paging done. I had a little bit of time after uni, and I got it figured out. But I will explain to you guys how I did it. And I will explain my code. Uh, but yeah, let's get started. So let's let me guys show you what I did. Okay, so as you guys can see, I had a little thing right here. GDT is done, IDT is done, timer is done, and keyboard is done, and paging is done. So we do have paging enabled. Um, shoot. Let me show you guys the code for it. So I had a page called mem.c, right? And I commented it out for you guys so you could kind of understand it, because paging was like so hard for me. As you guys seen, it took me 8 days to get it done, or 9 days to get it done. Like, this stuff is crazy. But I commented everything out, and I updated my GitHub repository, so you guys could take a look at that. And yeah, here I'll explain everything. So this maximum or minimum physical frame. All right, this is our maximum physical frame. This is the total amount of allocated frames. This is the amount of virtual pages. Um, Number of page directories, number of page frames, and then this is our bitmap right here, our bitmap array, and it divides the number of page frames by 8, right? And then we recreate our page directories, and we also store our page directory used, right? So that's all our variables for now. Now here is our physical memory allocator, right? And technically what it does is it calculates the high and low in memory, and then it clears the bitmap with a memset. So that's pretty what it does. It just sets up, everything, and sets up our bitmap. And then down here, this function, get our current page directory. We have to use a little bit of assembly, but we get it from the address cr3, and we store it in this PD value, and we add it to our kernel start, which is 0x c 0000000, whatever, right? And then we return that value. Okay, now this is to change the page directory, right? So this is a little different. We store the page directory with a cast to PD, right, or what we put on it, and then we subtract the kernel start. So it's kind of we're reversing what we're doing here, right? Subtract the kernel start, and then instead of taking it from CR3, we put it into CR3. So as you can see here, we move 0 into EAX, and then EAX into CR3, and then we move PD into CR3, right? Okay, now here we cyc the page directories, and what this technically does is it iterates over the pages and clears like certain flags to see if each of the directories are used. Yeah, you see we just iterate for the number of page directories, and then we set the certain flags to that, right? This is our memory mapper. It maps virtual addresses to physical addresses. Pretty standard. Having to explain all this would take forever. And then here, this allocates the free bit in the bitmap and stores it in the page frame. All this code. You guys can copy it if you want. And this is the function we call to set everything up. And it stores it in the table, right? So, and then we validate this address too, and then we memset, all these, and then this validate function right here, it checks to see if the address is in sync with the memory, or the page tables are in sync with the memory. So we use the invlpg instruction for assembly, and what that typically does is it checks to see if it's in sync with memory. So that's pretty much what this does, and it and we set up everything right there. I explained it to the best of my ability. I'm sorry, guys, if you still don't understand. I could I'll try to explain it better if you guys want me to. But yeah, that's pretty much it for paging. We got paging done. So yeah, now we can get started with the file system, right? And I wanted to open up Chromium, right? I wanted to go to the OS wiki, and I wanted to see all the information on ext2, because I want that file system to because I want to use that file system. Hello, Chromium? Let's go to the OS wiki. Instead of cross compiling. Check the file system. Okay. Second extended file system, right? Ext, I think Linux is ext4. You could use a lot of file systems, but it's the most common one for Linux. And it's common against Unix-like operating systems. So the block in the file system divides up disk space into logical blocks of continuous space. The size of the blocks need to be in the same size as the sector size of the disk the file system resides in. The size of the blocks can be determined by reading the field starting at byte 24 of the superblock. I don't know what the superblock is. So let's click on it. What is the superblock? It's the first step in implementing the ext2 driver. Find, extract, and parse the superblock. So okay. What's an inode? What is an inode? An inode is a structure in the disk that represents a file. This does not contain data of the file they represent. So it's kind of like a it's kind of like a node in a linked list, right? The linked list is all the file directories. All right. It's kind of what do you call it? The file system kind of looks like a binary tree, right? Different levels of the binary tree are different page directories, and I think that's what the inode is. Yeah, and then the super block's the big block. Now, how do we put this into descriptor table? So these are the flag values for the different superblock file system and etc. Okay, but do they have something for implementing it into? There's a lot of shit here. Sticky bit, read permissions, write permissions. So we need. So there's different prescription or permission values. Um. Okay. Maybe we could try a fat file system, but the ext seems not complicated, but or it's actually very complicated, but okay, wait. Ba, 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 ba. La-di-da. Big mouth, la-di-da-da. Bum, bum. Here we go. Okay. Wait on some beautiful from your old ways. Pay forgiveness. Watch it now. Here he comes. Like Jesus. So the one guy in the Discord was telling me, that I should probably make a virtual file system in memory before I try, creating or before I start creating the ext two file system. Um, and I kind of agree with that. Um, but yeah, so I create this temp file system, right? Um, oh, this is what an inode is. It's a oh okay, I know what it is. Never mind, never mind, never mind, never mind, never mind, never mind. Read, write, open, close. So in this example right here, the one I'm looking at right now, um, Here he's using memset free. He's copying over memory. Let me look up examples. Oh, this is Torvalds. This is Torvalds? Okay, hold up. Torvald created this? How many lines is it? Oh my gosh. Here's the super block they were talking about. The inode operations. Okay, but say ext2 ext2. Now, where is the C file for it? Is it in super? ext or ext message. You know what? This is kind of crazy. Oh, here we go. Oh, it's in C++. Okay. Okay, it's not... Oh, no, it is. Why does that have to be made with C++, man? Manual Breuer. I'll do an hour tonight. Maybe. We'll see. Inode count, blocks, reserve blocks, free blocks. What are all these memory addresses? So the superblock contains the information that characterizes the file system. Its main function is to indicate size of different parts that define the file system. The attributes selected for it are numMagic, magic number that identifies the file system, numblock map inodes, number of blocks occupied by the inode map. And yeah, there's a couple bitmaps for the inodes and blocks. And that's pretty much it. I'm going to read some of the code in this file. Try to see if I can make any sense of it. No, I'll read it with you guys too. CRC. Whoa, what is this? Lookup table? Let's CRC 16. Cynical redundancy check. I'm working on a library to provide simple, reliable communication over RS-23, yeah, whatever. I want to know what it is. Right, whatever. Right. Jeez, look at all these addresses. You believe people like created these? It's insane. Okay, whatever. That's super blusk. Start. Mixfus. Hold up. So there's that. Now where's the bread? Right. How does it write to disk though? Well, that's not helpful. Let's watch a video on it. Let me pause my music. Oh. This is just a presentation? CSC, where is this at? Algorithms Bioinformatics, University of Arizona. Okay. Okay, I'll watch this on my free time. I don't think you guys want to watch this. That would probably be a really helpful video. And I could share everything I learned with you guys. Oh, this is on the OpenBSD repository? Oh, wait, no, it's not. Oh, wait, no, it's not. Okay. Let me just make sure that everything... Okay, wait, you know what? Let's get to some code. Right. Def file system .h. Define system h and if. Okay. So let's go back to the OS wiki. So we have to access using LBA, and these different these sectors. Starting by, yeah, this is just not making sense to me. Okay. Kernel panic. So we need to create a structure with all these values in it. ext2 extended file system. And if you guys oh nah. Okay. Let's go into ex. Oh, this is the virtual file system. Yeah, we'll probably have to create a virtual file system first. You know what? Real quick, let's organize all this. Let's delete bitter. All right, we don't need that. Oh, and then also, yeah, let's get rid of this. We call the init memory function and get the upper memory from our multi-boot info, right? And then store it in all this. All right, times 1,024 bytes. And then the physical memory allocation start, which is this memory address. I don't even know. I copied this code, but no. This makes sense. So we get the boot mod address, and we add 4 to it, and then we dereference the pointer, and then we add this mod 1 to this 0xFFF memory address, and then we add, 0xFFF to it, and then we pass it through into init memory, right? And then we play with that. Let me delete all this too. Right. Okay. Yeah, let's organize this though. So I want to make a directory for GDT. I want to make a directory for IDT. And then we could throw all these values in it. So gdt.c, gdt.h, gdt.s, idt.c, idt.h, idt.s. Right, and that organizes it a little bit. We want to do gdt slash and then idt slash. In our makefile, source slash idt idt, and then gdt slash gdt gdt. So this makes it kind of cleaner too. And then let's try running it. Oh shoot. Also, let's remove file system for now. Let me include back a directory. Now we cd into IDT. And we just do oh no. IDT is in this file. And then we should be good. That at least knocks out right, because we need interrupts for our timer. IDT dot slash. Okay, where's this at? Keyboard. IDT. There we go. So at least it's a little more, memorized, or what do you call it? Organized. I'm also gonna do some memory stuff, and I'm gonna move memory into here, memory.h, and then malloc in here too. And yeah, now let me go into malloc. Okay. Okay. Malloc memory. And then make it. All right. First one is malloc. Car waiting. Okay. 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 So that's organized memory organized or everything. I can't even speak today. So that should be kinda everything so far. Um, so yeah, that's everything so far. So let's go back to the file system. So let's make a directory. Delete this. I named it wrong. It's kind of ridiculous. I gotta learn the Linux command for deleting. Let's name it fs. So first thing we'll have to do is a virtual file system. If and def VFS VFSH, and then down here we define undefined. Okay, that's that. Here we'll go back into this, the H, and who's texting me? Okay. 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 So we'll have to define create, and the address is 0B001. Define create all 0B010. Now we have to define read only mode, write only mode, and then read write mode. Yeah, I think I'm gonna. Okay. Okay. Define only 0B01. Okay. Read only, read write mode, and it's 0b11 find right only 0b11. Okay. Wait. No, this is 10. Okay, so that's that. Oh, shoot, it's late. All right, guys. I'm gonna have to call for today because I got school tomorrow. I love all of you guys. Thank you. Oh my gosh, this is all jacked up. I'm sorry, guys. Anyways, I'll see you guys tomorrow. Awesome job today. I hope I explained paging or my code to you guys pretty well. And yeah, I'll see you guys tomorrow. I committed to my GitHub today, so I have everything up to paging updated on the GitHub. So, yeah, awesome video today, and I will see you guys tomorrow. Bye, guys.